In this video, we are diving into an essential topic in computer architecture and digital logic, which is binary multiplication. I will try explaining 4 different methods used to perform the binary multiplication, which are sign extension method, Booth's algorithms, and Robertson method, and the last one, which is two correction method. And my reference is the book Computer Architecture in Practice by Swavamir Grace. I'll put its link in the description, and I really recommend this book because it was really life-saving for me because I was struggling to understand computer architecture, but this book changed everything. It's written in a very simple and clear way, and you don't have to be an expert to follow it. The explanations are straightforward and the language is very accessible, and there are so many exercises and solved examples which will help you practice and test your understanding. So let's get started. Let's start with for example, sign numbers. For example, let's say -5 and -7. -7 and -5. First of all, those numbers are in the binary way. Let's write their two complements form. So first of all, we will make the 7 into the binary system with the basic way. So here we have the 7 and here we have 2. So here we will have 3 and 1 is the remaining. Here we have 2, we have 1 and 1 is remaining, and here is the 1. So the 7 will be 1, 1 and 1. For the 5 as well, 5 and the 2 will be 2, and here's the 1 is the remaining. Here will be 1 and 0, the remaining is 0, and here we have the 1. So we will start from here, 1, 0 and 1. Okay, here's the binary form of 7 and 5, but we have -7 and -5, so we will write their two complements form for these two numbers. So we have the way. First of all, we will have to add the sign bit. Here is the 7, 1, 2, 3, and let's say it is +7. So in this case we have to put a sign bit which will be in the place of the most significant bit. So here we have 7 in the binary form, and for the 5 we will add the sign bit which will be 0 in case of 5. Now we will try to write their two complement form. Just complement and it is complement. Okay, so how can we transfer the 7 and 5? We have this way. First of all, we reverse every bit. For example, here we have 1 1 1 and 0, so we'll reverse it. It will be 0 0 0, and instead of the 0 here we will write 1, and then we will add 1 we will add 1 for the to the number. So here 0 plus 1 will be 1. Here we have 0 0 and 0. For the 5, the same thing. Here we have 0 1 0 and 1, and we will add 1 at the beginning of the number. So here we will have 1 1 0 and 1. So at the end here we have -7 in the binary way, and here we have -5. And if you want to make sure you have this way, for example, here we have 2 to the power of 0 multiplied by 1. Here we have 2 to the power of 1 multiplied by 1 plus. Here we have 0 multiplied by the 2 of the power of 0 and 2 to the power of 2. And for the sign bit, in case if it's 1, we will for the sign bit is always minus, so minus 2 to the power of 3. Here we will start with 0, yeah, 0 1 2 3, which will for the index, so but for the values it will be 1 2. So let me write it in with another color, say green. For the value this will be 1 2 4 and -8. Here we will have 2 minus 2 to the power of 3 multiply with 1. So here we will have -8 plus 0 multiplied by a number will result in 0. Here we have 2 multiplied with 1 will be 2 plus 1, which will result to -5, and we know that our number is correct. So this is a quick explanation for how to transfer a number to it is 2 complements number. So now let's get started with our first way, which is sign extension method. So in this way, in this way we have to add some. So the sign extension method is often used when we multiply signed binary numbers. Here how it works: first we make sure both numbers are in 2 complements form, as we did here. The second thing, we will extend the sign bit to match the required bit length. So for example, here we have 4 bits. 1 2 3 4. So we will extend it, like we'll multiply it to 4. For example, we will if we have 4 bits, we will make it 8. Sorry, if we have 4 bits, like in this case 1 2 3 4, we'll make it 8. If we have 8, we'll make it to 16. So let's complete with our example. So here we have -7 0 1 1 0 1, and here we have the -5. Okay, here is -5 multiply with -7. So we will extend the bits. How can we extend a bit in the two complements form? By just repeating the most significant bit, which is the last bit here. So in this case we will just repeat it 1 2 3 4. The same case here 1 2 3 4. Okay, and now let's start with the multiplication. 1 multiply with 1 1 1 0 1 1 1 1 and 1. The 0 will be 0, but in the second number we move one step. So here we will start from here 0 0 0 0 0 0 0 and 0. In the same case here we move one step to the left 0 0 0 0 0 and 0. And for the one we will just repeat the first number 1 1 0 1 1 1 1 and 1 3 0. And for the next number we have 1 1 0 1 1 1 1 and 1. The next number we move one step 1 1 0 1 1 1 1 and 1. The next number 1 1 0 1 1 1 1 1. The last one, which is 1 1 0 1 1 1 and 1. Sorry, I made a mistake. No, here we have the last one. Now we will just add 1. There's no number here, so it will be 1. 1 plus 0 will be 1. 0 0 0. Here we'll have 0. 1 plus 0 plus 0 plus 1 will equal to 2. So we add 0 and we put 1 here. We carry 1 here. Here we have 1 plus 1, which is 2. And so we'll put the 0 here and put the 1 here. Here we have 1 1